Hello YouTube and welcome to Homebrew. Today's video is all about a special piece of technology I like to call Homebrew Propellers. That is HBP for short. So I've got a couple pre-built things. I've got a plane, some other junk I'll explain later. So first off, this plane, it's really simple, just 4 wings and a tailplane, but it's got a couple special features as well, such as these rotators and this gyroscope. I'll explain what those are and why we need them later on, but for now just know that every HBP plane will need them. So let's get started. What is an HBP exactly? An HBP is a set of several wings that spin around an axis. So this is a simple HBP. As you can see, it's 8 wings, and it would be spun around this axis here. It doesn't matter whether it's clockwise or counterclockwise, but I'll go into further detail on that later on. So this is a bit more complicated than a normal HBP would be. This one allows for a variable blade angle mid-flight. As you can see here, I've now set the blade angle to 15 degrees. This is measured as parallel off of this plane here. As you can see, it's 15 degrees off the plane, so we call this 15 degrees. This is the blade angle of the HBP. We'll go into further detail on that later on, but for now, this is just how you identify it. So an HBP, like I just said, is a bit more complicated than just spinning wings, though it is essentially spinning wings. You have to spin them in a special way, and for that we use an HBP engine. I've pre-built one here. This is what it looks like inside the tuner. I'll go into further detail on all this later on, but for now this is what it looks like. So I'm going to just go ahead and mount a couple of these on there, show you how to wire them up. So here's a couple HBPs, and here's the engine. I'll go ahead and mount the engine first. Boom. There's one. And there goes the second. Notice I mounted 2 HBPs. It's always important that HBPs are mounted in pairs. As the first HBP spins clockwise to generate thrust, it also happens to spin the vehicle counterclockwise, because an HBP doesn't just make forward thrust, but it also makes a lot of rotational energy. So as this one spins clockwise, it spins the vehicle counterclockwise. To mitigate this, use an identical HBP on the opposite side, or really anywhere else, as long as it's equidistant from the center. The second HBP will spin counterclockwise, and it causes the vehicle to spin clockwise with the exact same force as the other HBP. So in theory, it should negate the other force, so it should have a net total of 0 rotation. This is exactly how we want the plane to fly, so we're going to fight to make 0 rotation. This is why we also have a gyro attached. The gyro dampens rotational energy. So while this system of using 2 rotors may not be perfect, the gyro helps mitigate those losses. Because if one happens to be slightly more powerful than the other at a certain point in time, the gyro will absorb some of the difference, and we'll see even less of the effects on the vehicle, if any at all. Hence why we always use a gyro. Now to hook up the HBPs and the engine. So these are the blades. I've hooked them together with modified boxes for convenience. This shift box I've grabbed allows me to change the blade angle while mid-flight, like so. And these are the rotators that we mount them on. We can spin these with the HBP engine that we built before, like so. I'll hook it to my throttle so I can actually set a speed for it to rotate at. And there we have it, folks. HBPs. Now notice these are currently spinning in the same direction, so I need to invert one of them. I believe I'll invert this one, like so. I need to fix this one to be 1 coefficient, like so. Next, we need to invert the blades on one of them. This one is not spinning correctly, I believe. Yeah. So we need to invert the blade angle on this. To do that, I need to select the modify box I placed earlier, like so, and just stick invert on it. And we're done. This should be a working HPP powered plane. We'll see that in flight later on. Alright guys, it's time to show you how to actually build an HPP. So first off, go ahead and make a new assembly. Close out the original thing. We don't need it for now. And the first thing I'm going to do is I'm going to spot up a couple X pipes. We're going to use these later on to mount our wings to. If you remember, an HPP is quite simply put a bunch of wings spun around an axis. So we're going to do exactly that. I'm going to take a bunch of wings. My preferred wing is the X15 tail wing. Since these wings don't have a flap, it condenses the tuner much more. Now that I mounted the X pipes, I'll grab a couple straight 2s. There's several ways to mount HBP wings on there. This is just the way I prefer for an 8-blade HBP, like the one I'm showing you. Flip these around, like so. Next, I'm going to install the rotators. We're going to use these to change the blade angle of the HBP later on. Rotate these appropriately. Like so. And now we're going to mount the wings to them. Like so. Next, we spawn up a modify box. This will help greatly. Since we're saving this as an assembly, later on, instead of having to do this process like I'm doing now, where I drag each rotator over and over, and attach each thing, we're going to hook up this modify box to each one. That way, later on, when I spawn this in, I only have to hook up the modify box. Now I'll just double click these rotators and change their blade angle to 1. Not blade angle, angle multiplier. Sorry about that. And we can make the modify box set to max of 45, min of negative 45. Set up offset to check 15. Looks like everything's all set. And this HBP is good to go. We are done with this. Alright guys, now that we've completed the HBP itself, if you recall from earlier, an HBP requires an engine in order to spin properly. So now it's time to show you how to build an HBP engine. So we'll start a new assembly, close out the one before. We'll open it back up later, but for now we don't need it. Just to get rid of all the distractions. All you got now is this one little block. So for an HBP engine, the order you place the blocks are extremely important. So pay close attention to how I place these blocks. If you remember from before, we had a shift, combine, transistor, and toggle. And that is the order we're going to weld these in. I'm going to spawn a first shift box, like so. Next I'll spawn a combine box, and weld it second. Third I'll have a transistor. I'll weld that third. And lastly, a toggle box. Now, where you weld them doesn't matter, just the order that you weld them in. Next, we'll go in the tuner and show you how to link these things. So just spread them out in a way that you can easily tell where they are. This is the way I prefer to do it. Hook the output of the shift box into the input of the combine. Output of the combine into the input of the transistor. Dumb name, I didn't make it. Output of the toggle into the trigger input of the transistor, and the transistor's output into the combine. What this does is now we can set a value on the shift box, send it to the combine, which is set to add. It'll add the two inputs, and pass it to the transistor, which will then pass it back to the combine box. So each update, it'll increase by the shift box's amount. So time for settings. Transistor needs to be triggered by default. The shift box speed doesn't matter. I prefer 22.5. The minimum needs to be 0 and the maximum 90. These are important. I'll explain why later. Next, with the combine, the maximum needs to be 1E plus 38. This will allow it to count up as high as it wants. The minimum can be 0 or anything below. I'll just set it to 0 for convenience. And this is the completed HBP engine. Now to explain how and why it works. So normally when you build in the tuner, each link from one box to another has a 1 tick delay. So normally the shift box from its output to the combine's input would be a 1 tick delay. Because the way we placed these when we welded them, not the way we placed them, but the order in which we placed them, order in which we welded, rather, that will cause this delay to go away. If two boxes are welded and then, I guess, connected in the tuner, that's the word. If they're welded and connected in the same order, then there'll be 0 tick delay between the two. So we went shift, combine, transistor, toggle. So the output of the shift into the input of the combine has 0 ticks of delay. The output of the combine has to the transistor's input has 0 ticks of delay. And then since we're going backwards from the transistor to the combine, we now have a 1 tick delay from the transistor's output to the combine's second input. This causes the combine to go combine, transistor, back to combine in a 1 tick loop. This is important because you now have your FPS, number of ticks per second. They're equal, your LTR, logic tick rate, is equal to your FPS, frames per second, which is displayed up here. So we have that many number of ticks happening every second. It's quite important to be synced up pretty well. So now we have this combine box now increases by the shift box's amount every single tick. I'll explain later why we use these minimum and maximum values on the shift box. But for now, this is the completed HBP engine and how it works. Alright guys, now that I showed you how to build an HBP and how the HBP engine works, it's time to mount them to the vehicle. So I'll go ahead and spawn up 2 of the HBPs that we built before. It's important that you spawn up 2 instead of shift welding like normal, because there's a bug with assemblies where if you shift weld them, each box or each tuner object must be reset for it to work properly. So we're mitigating that by just not even shift welding. So we got 2 of the HBPs we built earlier, and we got an HBP engine. I'll just go ahead and weld that to the vehicle as well, like so. And now to hook them up in the tuner. So if you remember, these are the modify boxes we hooked to before. These will allow us to change all these rotators, even though we can't access them, by just connecting to this modify box. So I use this shift box that I've already hooked to my seat, and this will let me change the blade angle of each of the blades on these HBPs with just a simple 1 connection, like so. Next, we take the HBP engine, we hook it to the rotators, these 2. This will allow the HBP engine to spin them. We hook the seat to the HBP engine so we can control it, and we hook the HBP engine speed up to a display so we can see how fast it should be working, like so. It's connected, don't worry. It's a bug with the game. So now we've got everything hooked up, it's ready for a test flight, but before we do that, it's time to explain some of the things of how things work. So, I said before that the blade angle matters a lot. As it turns out, as you near 90 degrees perpendicular to this plane that we said before define a blade's angle, As you near 90 degrees, your drag increases exponentially. This is a huge problem because drag is bad. In fact, as you reach 90 degrees exactly, drag is maximum. There's no more drag than you could possibly have with those set of wings. So you always want a low blade angle. Since lower blade angles produce less drag, drag slows you down. You don't want drag, so you do a low blade angle. The problem with this is that the higher the blade angle, the more thrust the HBP can put out. So it's always important to have a balanced mix of both. This is why we vary it in flight. You start off with a high blade angle because it puts out high thrust but low maximum speed. So it is great for acceleration but not high speed. So you would lower it in flight to shift based on whether you want acceleration or speed at the moment. This one is set so I can also set it to reverse, like so. This allows me to go backwards. Now it's time for some of the finer, deeper little things that most people wouldn't even want to know. Now, why did we set the engine's max and min values on the shift to 0 and 90? As this turns out, this is the number of degrees the HBP will spin each tick. That's why we built it specifically in this way before. Since it adds this value to the combine box every single tick, it changes by that much every tick. This is hooked to the rotator with a coefficient of 1 or -1, either way. And this means it'll change that many degrees every single tick. This is called the degrees per tick, or DPT for short, of the engine. This system that I showed you how to build, this engine, since it's got this shift box, we can vary the DPT mid-flight and change our throttle power. Now, as it turns out, since between two ticks, this blade will have moved from here to here, and then again here to here, 90 degrees at max. When you change the blade, the DPT of the engine, the game, since it works in ticks, it measures the distance between here, position A in tick 1, to position B during tick 2. And that is the force that the wing will exert. Now, you might think that it would have the greatest distance if it rotated 180 degrees, or if it rotated even 360 degrees, because it went from here all the way back around. But wrong. It's not how much it traveled, so to say, in degrees. It's how much it actually moved in distance. So as it turns out, 90 degrees is the fastest you can make an HBP go, with the greatest distance between point A and point B, and actually have a net rotation. 120 degrees is pretty close. It's right about here, I believe. It's a close second, but it's not quite as efficient as 90 degrees. So as you near 90 degrees per tick in thrust, you increase your force per second, I should say, or force per tick, rather, which then increases force per second. But once you pass 90, it begins to decrease until you get to 180, since it's essentially just shift the wing from here directly across. There's no net rotation, so there's no net force going them at 180 degrees per tick. So there's no force at all from the HBP at all. So as you near 180 degrees, your force will decrease. As you then near 270 degrees, it's now as if your wing had gone backwards. So now the thrust is reversed, and it's negative. As you near 270 degrees, the thrust now goes up again, but negatively. So it increases to a larger negative value. As it goes from 270 back to 360, it then decreasing a negative again. So it's nearing 0 again. Why this matters is because, well, you never really want to go above 90 degrees per tick on your HBP engine. And as you see, since these are mounted 45 and then 90 degrees apart between these two, when we're at 90 degrees per tick, you can't even see that spinning. This is just a cool side effect of how I've mounted the HBPs. If you were to, say, pop one of these wings off, you could then see it rotating, sort of. But that's just a good way to note that you're at maximum force from it. So, I hope this video was helpful to you guys. I'll stick around and show you a test flight of this thing. But, for now, I think we're done. Thank you guys for watching. Alright guys, it's now time to test fly the HBP plane that we built before. So, here we go. Bear with me, this is going to be a rough takeoff. I didn't design this plane for takeoff ease. It's just going to be flying ease. So again, I mentioned before, we're now at 90 degrees per tick, so this is the maximum thrust that it's going to get. As you can see on the screen on the left. On the right we've got our blade angle, which I'm now going to shift to negative to get off the ground. Like so. And now we shift it back to positive for forward thrust. And off we go. It's pretty stable in flight thanks to the gyro back there. Honestly, it's quite maneuverable plane already. I didn't hook up a speedometer for reasons unknown to even me, but trust me, this thing can go pretty fast. Just watch it hit supersonic in a second. There we go. Now, I also mentioned before how the blade angles matter. And generally, the lower the blade angle, the less drag, so the higher top speed. But the higher the blade angle, the more acceleration. There are a couple points of note these. The maximum of 45 degree blade angle. That's a special one because it's the most acceleration efficient. Once you go above 45 degrees, you're now really not making the most of what you got. You're just increasing drag while decreasing thrust. So the highest acceleration comes from 45 degree angle. Next is a nice balance between top speed and acceleration. It's perfect for taking turns. It's the 21 degree angle. Right here. This, in general, allows for the highest speed during a turn, since you've got high acceleration with still pretty nice speed. And lastly, you have the 3.5 degree angle right here. This, in general, allows the maximum speed of the vehicle. It takes a while to accelerate, as you saw before, but it allows for insanely high maximum speed due to incredibly low drag, while still somehow producing thrust. Anything below 3.5 degrees will not generate enough thrust, and you'll start slowing down again, while still having extremely slow acceleration. So it's good practice to cap and min your blade angle to a max of 45 and a minimum of 3.5. Now, some planes, the minimum will be 4.5, or in extremely heavy planes, it might even be 5. But in general, it's right around the 4 degree angle. I think that's all I had to cover. So, hope you guys enjoyed watching and learned plenty from the tutorial. I'll be back with more tutorials on other videos. But, thank you guys for watching. That's it. All I got for today. Hope you guys noticed the potato in the video.